Hello and welcome back. Now C# is an object-oriented programming language. This means it's a concept of programming which tries to make the creation of complex applications simple by relating things in code to their counterparts in the real world. Object-oriented programming language is generally shortened to OOP. Initially it looks as if OOP is making the applications more complex. But as applications grow and need to change, the concept OOP being applied to your applications makes them more flexible and less likely to break. Now the reason I'm discussing OOP in this lesson is because you are surrounded by OOP. You may not have realized it, but C# is object-oriented, and in the first lesson you're writing object-oriented code. It's useful to understand the basics of OOP because it'll make a lot of things easier to understand as you go along. Now the basic building block of object-oriented programming is a class. A class can be thought of as a plan on how to build a house, or a recipe on how to make biscuits, or a sheet of music for someone to play. Now here we need to point out the plan itself is not a house, the recipe is not a biscuit, and the sheet music is not a performance. They are basically instructions on how each of these should be performed or built. They're not the same thing. You can make many houses from the same plan, and each house is an instance of the plan. Whilst the interior may differ, essentially they are the same house. We can bake lots of biscuits from the same recipe, but each biscuit could be slightly different in shape or thickness, but they're still from the same recipe. Hundreds of musicians can play the same piece of music. Each one would have a slightly different style, but it's still the same piece of music. So that's the prime difference between a class and an object. A class is the plan, an object is an instance of the plan. So you could create many instances of a class, and each instance is made from the class instructions. Whilst each object instance can have different properties, they're all still the same class. So for example, if I have two buttons on my form, and one is small and grey and the other big and blue, however, they're still buttons except that each instance of the button has different properties. So a button in the toolbox is actually a class, and when we drag it from there onto the designer surface, a new instance of that class is being created. Whilst we can change each property of each of the buttons to make them look different, whenever we place them on our designer surface, at the end of the day they're both still instances of the button class. So when looking at the form, we should note that when defining a form we're actually defining a class, public class form1. When we run our application, an instance of our form class is created. So that shows that you have been working with OOP already and it's all around you. So now we shall look at how to create and use our own classes and objects in our applications. So we'll begin by adding new item for project. Select class from the templates. Rename class 1 to car.cs. So it adds car.cs file in our Solution Explorer, and it opens up that file into our main area. I also have a definition for class, which is class car, and we have opened and closed parentheses. So whilst there's nothing within my class, we've defined a class. So now that we've created a plan, so to speak, we can create an instance of class. So when someone clicks on our OK button on our designer surface, we will create an instance of the new class. Right now it's a type similar to any other data type. So my car equals new car. Now nothing would happen if I ran the application, but I'll just talk about defining a class and creating an instance of that class. I can put both lines of code in just one line by doing my car equals new car. So this is similar to when we created a string array. We did string, my array equals new array. So now we can talk about the keyword new. It actually does some interesting things behind the scenes in your computer's memory. We can think of the new keyword as a way of creating a new copy of our plan or a new instance of our class. So as we said before, it's like building another house from the same plan or baking another batch of biscuits from the same recipe, but the new instance of your class is distinct from all other copies of your class. Before using your new instance, you have to use the new keyword, otherwise an error message will appear when you try to compile or run your application. So now we'll add some properties to our class. In the button class, you'll see that each instance of the button has a set of properties in the property tab, which we can alter, and it'll change the appearance or behavior of that control. As well as this, we can create properties for the objects that we build, so our car class can have its own properties. Now, let's discuss the two parts of a property in our car.cs file. So first we have something called the field, and that is a variable that maintains the value of the property behind the scenes. Then there are the methods that let you access that property, so it's necessary to make this distinction between the two parts. So we'll build a field, a private field of a type string called make. Our car will have a make and a model and mileage. So I've defined free fields similar to the way I defined variables in previous lessons. We've used the keyword private, which is the biggest difference. Now let's look at property, which is another part of our properties. Remember, when defining a field, use the keyword private, and when defining a property, use the keyword public. So public string make. Then add two more properties. Now you'll see that as we define the property part of the properties, they have two distinct pieces. You have a get statement and a set statement. The get statement lets us return the field back when it's requested, and in the set statement you write code to assign the underlying field value to whatever it's being assigned to. So here the C# code editor highlights the keyword value in blue. C# creates this for you automatically, and it's basically a generic parameter name. Now I want to use these properties in my form1.cs within my code. I can now set the properties of my car. Now you can see I have make, model and mileage that are displayed within the IntelliSense. So I could set the make equal to Oldsmobile and set the model equal to Cutlass Supreme and set the elapsed mileage equal to 200,000. We'll then set a breakpoint and see what happens. So run our application, click my OK button. I get my breakpoint stopping here, then I'll select the OK button. This then goes to the set statement of my make property. It executes that and passes in the word automobile to the make value. Right now the make value is null and it assigns that property to make, and you'll see that it's set that value. This will also happen for model and for elapsed mileage. This will also happen when we use the get statement. So we'll do messagebox.show mycar.make. Then we'll set our breakpoint at the line of code and run it again, then click the OK button. Now I'll execute this line of code and select the step into. So you'll see it goes to our property and returns the value, our private field of make, back to the messagebox.show method. And that shows a message box with the make of my car object, which is set to Oldsville. So basically we can define properties which show the real world properties, the descriptive elements of a given object. Code then allows us to set the values of those properties that distinguishes one instance of our object from other instances of that same object. Classes can also define methods as well as properties. So when we write code inside an event handler, it's the same as writing code inside a method. So basically, a method is a named block of code that can be called from another place within our code. They're also known as functions or procedures. In object-oriented programming, it's more appropriate to use the term method, however. A property tends to describe an object, what something looks like, for example. A method is more of an action. So if we take dogs as an example, if breed property of the dog is a golden Labrador, it might run or jump higher than Chihuahua. In terms of cars, there may be a method of our car called drive. Drive is something that we expect our car to do, but drive could mean various things, depending on what we want our application to do. So, if we were to run an accounting program, we would possibly use the drive method to increase the elapsed mileage property of the car, or to work out the cost of how much petrol is being consumed, or the wear and tear of the car. A method can take parameters. These are values which are used in the body of the method's code block to modify how it works. As many parameters as possible can be used. So to define a method, go to the button to click Event, and we'll just paste some code. So the method here is public integer, add two numbers, passing in first number and second number. This example is to show how parameters can be passed in. You can define the data type of the parameter, in this case an integer, then give it any name you want, but just make sure it's not the keyword which is used by C#. A second parameter can be added separated just by a comma. We named our method add two numbers, and both parameters are within parentheses next to our method. We've also defined this method as an integer, so a method can return a value or not return a value. If it doesn't return a value at the end of executing the code block, then it's a void method. So once it does its job, nothing is returned back. So if you see, we have public void display message. There's a message parameter of type string. This method shows a message box with a message on there. Here we are returning the sum of first number plus the second number. So if we call the add two numbers from our application, so int result equals add two numbers, then type 3 and a 5, then messagebox.show result to string. Then run the application. And we see the value of 8. So that's how it was possible to call our method passing in values, getting the result and displaying them in messagebox. Now, instead of using the messagebox.show, we can call our display message passing in result to string. We'll get the exact same thing because display message just displays a message box. But there are two different ways of using these methods. One method returns a value. We then take it and use it within the application. The void method just does its job and doesn't return anything. The other thing we could do is call display message, and rather than creating the results variable, we can just add two numbers such as 3 and 5. This will return an integer, which means we have to do a toString at the end of this. So in one step I get a return value from this, convert it to a string, and then call the void method to display it on screen. So that's how we can call and use methods within our classes using the parameters, and also return values or not using return values by designating a void method within our class. So back to car class, and under my last property we'll paste some code here. I've created my drive method, so public string, return type string, call drive, then pass in an integer of the number of miles that should be driven. I'll increase the elapsed mileage to add the additional miles driven. We'll do some more calculations and then put the make and model and the new elapsed mileage into a string and return that from my method. Methods tend to be small, so generally it's best to perform these in two separate steps. But anyway, in this case it's a simple function. So back to form 1 and call mycar.drive, and we'll pass in 30 more miles. Then string new result and set result equal to mycar.drive. Then messagebox.show and whatever the result is. So the car now has 200,030 miles. We could just ignore the return value. So if we just comment out all of this and call mycar.drive, then go back to messagebox.show and then mycar.elapsed mileage to string to ensure the number was added. So we'll save and run our application. Now I forgot to add how many miles we want to go, so we'll pass in 40 miles. And so although I'm ignoring the return string, our method still did its job, which is it added 40 miles to the original elapsed mileage count. so we can get that value back out through its property. Now let's discuss variable scope. Every variable we define has a scope. This means a variable can be used only within the context of the code block or subcode block in which it was defined. So for example, in our button one click event, double click it and add some code and get a reference to my car. So my messagebox.show my car.elapsed mileage.toString. Now here IntelliSense isn't helping me. This means I don't have a reference to my car anymore. This is because my car variable isn't in scope anymore because it was defined in this code block in the button 2 click event. This means it's not global enough to be seen by my button 1 click event. So we'll move this outside my button 2 click event and highlight and drag and drop it. So we'll make it into a field of my form 1 class. Then return to button 1 click event and start again. You'll see my car shows up in IntelliSense. I get to the elapsed mileage and the toString method. So basically, by moving the definition for the car outside of the scope of one code block to a more global code block at the form level, everything within the form can access and reference my car. If I put this back into a button 2 click event, then only the button 2 click event code block can see it. If I then try to run my application, I'd get a build error. It says the name my car doesn't exist in the current context because we have taken it out of the larger context of our form 1 and moved it into the button 2 click. So then let's look at the selection statement as another example. If my car.make equals Oldsmobile, then inside our if code block, we'll create string my model equals my car.model. Outside the if code block, we'll try to reference my model. So then let's run our application and see what happens. What happens is we get an exception. The name my model does not exist in the current context. There are some blue squiggly lines and this won't work because it's been defined inside the scope of a more restrictive code block. If we move this line of code inside of the code block, it would work. Or if I move string my model outside the if statement, it would work. To make it work, we need to initialize the value. So now that we're creating methods and properties within our classes, scope is a very important concept. And we'll look at scope and private and public scope modifiers again in the next lesson. So see you again very soon. Until then, take care. Bye bye.